You know, in trig, some of the best shortcuts aren't actually new formulas. They're just clever hacks of stuff you already know. And today, we're going to look at one of the absolute best, the double angle formulas. The cool thing is, they all come from the sum formulas you've probably already mastered. So here's the game plan. First, we're going to see where the shortcut even comes from, and it all starts with a really simple question. Then we'll build out our complete formula toolkit. After that, of course, we've got to put them to the test with some examples. And to wrap it all up, we'll look at a super common trap you'll want to avoid, and get this, a surprising place this math actually shows up in the real world. Okay, so let's get started, and we're going to begin with something you're already familiar with. Believe it or not, the key to this whole shortcut is hiding in plain sight, right inside the sum formulas for sine and cosine. And here it is. This is the simple but kind of brilliant question that unlocks everything. Instead of adding two different angles, like alpha and beta, what if we just add an angle to itself? Like, what happens if we try to find the sine of theta plus, theta? All right, let's break this down. Step 1, we just grab our good old sum formula for sine. No surprises there. Now for step 2, here's that little trick we just talked about. We're going to set both angles to be the exact same thing, theta. In step 3, we just plug that into the formula and check out what happens. We get sine theta cosine theta plus another sine theta cosine theta. And hey, when you add something to itself, you just get two of them, right? And that leads us straight to our final formula in step 4, which is just so clean and simple. Sine of 2 theta equals 2 sine theta cosine theta. Okay, so now that we get the logic behind it, we can use that exact same trick on the other trig functions. It's time to build out our full toolkit of double angle formulas. And there you have it. This is the slide you're going to want to screenshot or jot down. This is your toolkit. We've got the sine formula we just figured out, and a similar one for tangent. But take a look at cosine. It's kind of special. It doesn't get just one formula, it gets 3. Now, I know what you might be thinking. Great, 3 formulas for cosine, more stuff to memorize. But trust me on this, having 3 options isn't a burden, it's a huge strategic advantage. It actually makes solving problems way, way faster. So where do these other 2 even come from? Well, they come from another tool you've definitely seen before, the Pythagorean identity. Yeah, that one. By just rearranging that famous identity, we can take our main cosine formula and do a clever little swap. We can either sub out the sine squared term to get a formula that only has cosine, or we can sub out the cosine squared term to get a formula with only sine. It's this power to substitute that gives us those other 2 super useful variations. So here's the bottom line. The rule is super simple. Just choose the formula that matches the information you've already got. If a problem only gives you the value of sine, you grab the sine-only formula. If it only gives you cosine, you use the cosine-only one. It's all about being efficient and taking the path of least resistance. Okay, that's enough theory for now. Let's grab our new toolkit and actually solve some problems. It's time to see how these formulas really work in action. Okay, example 1. We're given the sine of theta, but our formula for sine of 2 theta needs both sine and cosine. So what do? Well, our first step is to find that missing piece. We can use the good old Pythagorean identity to solve for cosine. Once we have both values, step 2 is a piece of cake. We just plug them straight into the formula. A quick multiplication in step 3, and boom, we get our final answer, 24/25. And this example is just perfect for showing off the power of having those 3 cosine options. See, here we're only given the cosine value, so for step 1, we make the smart choice. We pick the cosine formula that only needs cosine. This is awesome because it means we can skip finding sine altogether. We just jump right to step 2, plug in the value, simplify, and we've got our answer. So much easier. Let's just stop and appreciate that choice for a second. Using that cosine-only formula, that was like taking a direct highway to the answer. Clean, fast, efficient. If we picked the main formula, the one with both sine and cosine, we would have had to take this long, winding detour. We'd be forced to do an extra calculation just to find the sine value first. And that's not just more work, it's another place where a little mistake could creep in. Now don't forget, these formulas aren't just for solving, they're also amazing for simplifying things. The real key here is training your eyes to spot the pattern. Look at this expression, 2 sine 3x cosine 3x. That should look familiar. It perfectly matches the right side of our sine formula, right? Only in this case, our angle A is 3x. So we can just apply the formula in reverse, collapse that whole thing down to the much simpler left side, and what do we get? Sine of 6x. So much cleaner. All right, for our last section, let's switch gears a little. we're going to talk about a really common mistake that you definitely want to avoid, and then we'll look at where these formulas actually show up outside of the classroom. Okay, before we finish up, I really want to talk about the single biggest mistake people make with these. It's this super tempting but totally wrong idea that you can just distribute the 2 inside a trig function. Look, you just can't treat sine of 2 theta like it's 2 times x. It doesn't work that way. Sine isn't a variable, it's a function. It's an operation that's being performed on the entire angle, on the whole 2 theta. You can't just pull the 2 out front. I mean, think about it. You wouldn't say the square root of 16 is 4 times the square root of 4, right? It just breaks the fundamental rules of how functions operate. The only correct way to deal with sine of 2 theta is with that formula we derived, 2 sine theta cosine theta, period. Okay, so we've learned the formulas, we've run through some problems, we know the big mistake to steer clear of. But the big question remains, does any of this actually matter outside of a math test? And the answer is a huge, resounding yes. Take electrical engineering, for instance. When they calculate the power flowing through an AC circuit, the math gets messy. We're talking squared sines and cosines all over the place. But engineers have this slick technique called power reduction. And guess what that is? It's literally just our double angle formula used in reverse. They use it to clean up those messy calculations, which lets them easily find the average power. And that average power, that's exactly what your electricity meter at home is measuring to figure out your bill. You know, we started all of this today with a really simple question. What if we just add an angle to itself? And that one little what if unlocked this entire powerful toolkit for us. It really makes you wonder, doesn't it? What other amazing shortcuts, what other powerful ideas are just hiding in plain sight, waiting to be discovered in the math you think you already know?